So to establish what kind of design assurance level you need, DO254 tells you have to kind of do a functional failure path analysis. So the functional failure path is really defined as a set of interdependent circuits that could cause a particular anomalous behavior in the hardware that implements the function, or in the hardware that's dependent upon the function. So, basically, if you look at your function, and you have a set of other components, there may be hardware/software components, and then you have your complex electronic hardware component, and within that you have your circuits, more or less, that are kind of interdependent. What you're going to do is you're going to say, well, I'm going to perform a structured top-down and iterative analysis to identify, if a particular, identify particular paths in which failures do occur, and you're going to check out for these paths if the end result is a failure that either leads to a catastrophic function problem, etc., etc. So the same stuff that we did for safety assessment earlier on, you're going to just check out, okay, but in this case you're going to focus on a functional failure path, and you're going to do this top down. So you're going to look at the system level, you're going to check out, okay, what kind of hardware components does it have, and within hardware components it may have some complex electronic hardware like we saw in the previous slide. Then you're going to say, is there any circuit boards within that? Then within the circuit board you're going to look at sets of components, and then of course within these components you're going to have elemental level FFP. So in other words, the elemental like elements such as registers, counters, adders, filters, and op amps. So you're going to basically say you're going to break down the system into hardware components that you can assess, and then you're going to see if these failures happen. And okay, what are the kind of chains of events that could happen? Yeah. So based on those, you're going to establish the levels, and these safety assurance levels are kind of very similar to DO178C. And look, for example, level A, hardware functions whose failure or anomalous behavior as shown by the hardware safety assessment, the functional failure analysis, which is really the safety assessment that you perform on the hardware, would cause a failure of the system function resulting in a catastrophic failure condition for the aircraft. It could lead to conditions in which there will be a loss of the hull, or people get wounded or hurt, in the similar fashion that we established already in module 1 and later on this system safety assessment module. Yeah. So basically, it establishes 5 levels, just like we do here. Now, if you look at the assurance level decisions, basically when you begin the assessment process, you're gonna determine the functional failure path design assurance level, and you're going to find out if it's like level A or B, C, D, or E. If it's level A, you're going to check out, okay, is this a complex component or a simple component? If it is simple, you can just document the applicable fail-safe aspects, or how you're going to deal with making sure that when particular components or elements fail, the system overall is not going to fail. How are you going to reduce, how are you going to mitigate that the final failure condition that you got? Bring that risk down. Yeah. If it's complex, however, you need to come up with a design assurance strategy, and that various ways to do this are documented in DO254. So I'm not going to really talk too much about it. I think in the handouts they allude a little bit to some of the methods that you could do. Yeah? So, and of course, if so in other words, DO254 describes some of the strategies that you could use. Yeah? So then, of course, if the strategy is adequate, you're going to document the applicable fail-safe aspects and the design assurance approach that then gets approved. So what I did is, for each one of these green blocks, I gave you some more detailed language that comes directly from DO54 for your reference, since you don't have the standard available. So here I kind of reiterate them. Yeah. So basically, what the next set of slides, and I won't go through these, I will talk a little bit about some of the objectives and activities. So I don't really want to go and stop at each one of these slides. They kind of you can just read them and go over them in detail. If you have questions, let me know. But basically, a couple of the things like requirements capture, I specify some of the objectives as well as the activities, and I mention those. And these really come directly from the standard and give you an idea. Now, one thing that you will notice is that there's a very strong focus on derived requirements, and the basic idea is very simple behind that. Is if you functionally want to do something, most of the logic design, for example, the circuit design is not necessarily directly traceable to that overall function. So a lot of the requirements, way more than before, are going to be derived requirements. You need to add on a whole bunch of stuff to get a particular function that operates. Yeah. So that's why in the activities, for example, here, you have system requirements, safety requirements, identification, to set design constraints, and you have, of course, determine derived requirements. And of course, you need to make sure that you feed those back to your system safety assessment, because they mean that you're going to have additional logic that you add that then must be reassessed because of the functional failure path. So a couple more of these. Okay, so this is what I got a little bit ahead of myself in this slide, but here, so here you can actually, so these are just additional requirements resulting from the hardware design process. Okay, so again, there's a whole lot of stuff in there relating to detailed design, and I'm not going to talk about all these slides. Now, one thing I will talk about is validation and verification just a little bit more.